All right, and we're back. So this is going to be a video going over section 9.5. Now notice how we did not do section 9.5 as it was like in the rhythm of chapter 9. Right? We did sections 9.1 and 9.4, and then we skipped to section 9.6. Yeah. The reason we did that is because the book expects us to graph quadratic equations and then find their zeros by hand. And honestly, that's not reasonable for you guys. And the reason it's not reasonable is because you guys actually get a graphing calculator. I know that this says Honors Algebra 1 on the very top. That's just because I forgot to take that off. This is Apple's notes for her Honors Algebra 1 class. So disregard that. I know what this class is. But in the online system for your end of course test, you don't have your charger? I'll get you a charger. You're going to want to do this by yourself. The online system for the book, or for the test, allows you to use this thing called Desmos calculator. Okay? The Desmos calculator is a very, very, very convenient tool for you to use because it allows you to graph pretty much everything that you want to graph. It's like almost like, I feel like it's almost like you're cheating almost. It's that good. It's that convenient. Okay? So what we're going to do is I'm going to go through and I'm going to teach you guys how to use quadratics with that Desmos calculator. Now, I believe I kind of just showed you a little bit about the Desmos calculator earlier on when we did systems. But for right now, what I'm going to do is I'm going to show you pretty much what we learned about quadratics and how it relates to what you can do on the Desmos calculator. Now, somebody asked me, so are we going to get tested over this? On my tests, like for my class, no. This is never going to be on a my class test because we can't really, I can't really allow you to use your laptop on part of it and not on another part. So remember what we're doing here in this the end of chapter 9. What we're doing is finding the zeros, right? We're finding the zeros. We found them by factoring. We found them by using the square roots, right? This is finding the zeros by graphing. Finding the zeros by graphing. I'd like everybody to open up a Chrome and go to, you can just honestly Google Desmos calculator. And I think it's just desmos.com, and you can go there. Desmos.com/calculator, whatever. Oh, I need a graphing calculator. Sorry. You don't want the scientific one. You want the graphing calculator. Graphing calc, not scientific, but graphing. It looks like for me when I Google Desmos calculator, it's the second link, not the first link. Now, again, this is going to be like a pop-up window in your test, in your end of course test. You will have access to this at all times during your test. It's not like it's only there on some questions, not on others. This is there the entire time, which is really nice for you guys. Here's why. Remember, the zeros of the function are where it crosses the x-axis. So let's everybody go in and type in your very first function there. For example, 1, that 2x squared minus 18. Just go into a box here and type in 2x. Now, you guys know how to do a squared? Do you guys see the number 6 on the numbers up top? Do you see how if you hit shift, it'll do the up arrow? That is going up to the second power. See, if I hit shift 6, it's automatically going to know that I want to put it up in an exponent. Again, shift 6 is the key. Shift 6, that's the caret up. So 2x squared. Now, I want to come down out of the squared to write the minus 18, right? So I'm going to hit the arrow over key, and that's going to bring me down, and I'm going to hit minus 18. You don't have to do y equals. You don't have to do equals 0. You just got to type in that 2x squared minus 18. You got to make sure that it's in standard form. So 2x squared minus 18. And then look at this. Look at what you see there. Does anybody not see that? Anybody not know how to do that? Anybody not following me here? Again, shift 6 brings it up into the exponent. That's how to do your exponent. To get it down out of the exponent, you just hit the right arrow key. Now, again, the zeros of the function are where it crosses the x-axis. And look at that. It tells you exactly where it's going to cross the x-axis. So what are the solutions to this equation? -3, +3, which makes sense. If I solve this algebraically by square roots, I add over the 19, I divide by 2, I get 9. It ends up being plus or minus 3, right? Plus or minus 3. That's the nice thing about this. It's doing the work for you almost, right? So everybody write that in there. The solution to that on your guided notes is plus or minus 3. Apparently somebody did their homework for the first time in a while. All right. So that's that plus or minus 3, that 2x squared minus 18, that was that plus or minus 3. Now what's incorrect, or what do I have to do to prep x squared plus 2x is equal to 8? What do I have to do with that? Get it all in one. So how do I get that 8 over to the left side? Subtract it. So go ahead and write it out. Obviously I can't write it out on my screen up here. I guess I could. I know it's going to be a little bit laggy, but that's okay. Subtract 8. Oh, I'll use it. Subtract 8. Subtract 8. So it's x squared plus 2x minus 8. Go ahead and plug that into Desmos. Okay. So I'm just going to delete what's there, and it's x squared, x shift 6, 2, arrow down, plus 2x minus 8. And you know what's also nice about this? If I zoom out a little bit, okay, I just do the minus sign. If I zoom out a little bit, you know what else it'll show me if I click on the graph? It'll also show me the vertex point. So if you've got a function, if you've got a quadratic on your test, on your state test, and it's saying, where's the vertex? You could just open this up, graph it, and click on the vertex, and it tells you exactly where it is. Where are the zeros? -4, +2. You see how easy that is? -4, +2. -4, +2. Questions about that? Okay. So go ahead and let's do the next one. 3x minus 5 is equal to x squared. How do I put this into standard form? What's the easiest way to put this into standard form? What's the easiest way? So I would subtract the 3x. I like to keep things positive. However, the reason I keep things positive is because it's easier to like factor and stuff. So does that, I'm thinking through this again. Does that actually matter in this case? No, because we're just going to put it on the graph. So let's actually subtract over the x squared. Sorry, again, it's a little laggy. -x squared plus 3x minus 5 equals 0. Sorry about that. So go ahead and plug that in. X squared plus 3x, negative x squared plus 3x minus 5. Negative x squared, negative x squared plus 3x minus 5. What do you notice about this? It doesn't have any zeros. It doesn't have any zeros. Did you forget the negative in front? Yeah. It doesn't have any zeros. So if this asked you, if the test asked you, where are the zeros, what would you say? You'd say none. You'd say none. There are no zeros. Yes, sir.
Why I kept like scrolling out and there's like some scientific information.
Yeah, if you keep scrolling out and scrolling out and scrolling out and scrolling out.
So does that just show that it just goes on forever?
Yeah. Yeah.
Like what if I keep doing?
Well, you know, it will eventually keep going. Just don't do that. Let's not get distracted like that.
You have to do that all again.
Yeah.
Just do that, or just do
Yeah, and you'll have to eventually zoom all the way back in. So don't do that, Carson.
Yeah, kind of figured that out.
Yeah. Okay. So go ahead and do D on your own. Do D on your own. What do I do to get this into standard form?
Subtract the 6x.
Subtract the 6x. Right. I subtract the 6x. So that's going to be going to get me 3x squared minus 6x plus 3. Let's graph that now. 3x squared minus 6x plus 3. 3x squared, 3x shift 6 squared minus, was it minus 6x? Yeah, minus 6x, and then a plus 3. I could zoom in a little bit there because I might not see it. Maybe I'm too far zoomed out. But does this cross the x-axis twice? No, just once, at 1. At 1 comma 0. Okay. So the solution to that equation is 1. Just a simple 1. Does that make sense? So please appreciate the work that your computer's doing for you, right? It's doing all of that algebra for you and showing you where the zeros are. It's even showing you, where is the y-intercept? Where is the x-intercept? Where's the vertex? It's showing you all of that. The only thing that it's not showing you is the actual dotted line of your axis of symmetry. But isn't that just the x value of your vertex anyway? So you know where it is. Like this one is just that x equals 1. Okay, now let's use this to answer some of these word problems as well. So you see it there. I'll show it on the screen here. A rocket is shot straight up from the ground. The quadratic function f of t is equal to negative 16t squared plus 96t models the rocket's height above the ground after t seconds. How long does it take for the rocket to return to the ground? And what is the rocket's maximum height? This looks like a very daunting problem right at the very beginning because it's asking me for a lot of information. However, if this question is on your state test, this is easy peasy because you have this calculator. Let me show you how. Everybody go to Desmos and type in that function. Negative 16. Now it says t, but let's use x. That question. Make it very quick. And then it was it plus 96? Oh, I got it right here. Plus 96x. And again, I'm changing t to x. Now you may have to zoom out because what's it asking for when it asks for the maximum height? What point is it asking for? Right, which was called the what? What's another name for a maximum? The vertex. Do I see the vertex on my screen right now? No. I could drag it around, but let's see. Let's zoom out until we see it. 144? Yeah, and you can even click on it and it'll tell you the exact point. So what is the maximum height of this? 144 feet? Is that what it is? Feet? Yeah, it doesn't say. Let's say it's feet. Let's say it's 144 feet. How long does it take to reach that maximum height? 3 seconds. It takes 3 seconds. Now, how long does it take to return to the ground? Is it 3 seconds? 6 total. And how do I see that for sure? Look at the 0. It's 6 comma 0. Okay. I would have had to factor this or do something else to, or solve by, I couldn't solve by square roots. It's got a t value. It's got a b value. So I couldn't have solved this by square roots. I would have had to factor this down to find that 6. But I can use Desmos to just plug it in pretty quickly. Isn't that nice? Convenient, right? Let's take a look at the next one. The frog jumps straight up off the ground. Let me bring it up here for the folks playing along at home. The frog jumps straight off the ground. The quadratic function f of t is equal to negative 16t squared plus 12t models the frog's height above the ground after t seconds. About how long is the frog in the air? What is the maximum height of that frog? So again, if this shows up on if a quadratic shows up on your end of course test, pop it into Desmos and see what happens. I'm going to go here. The function was negative 16t, so I'm going to use x, shift 6 squared, arrow over for down, plus 12t, 12x. Now, I've got to zoom in a little bit now, right? Let me zoom in, because a frog is going to go a lot lower than a rocket. All right, we've got, here are all my important pieces to this. So what is my maximum height? I'm sorry, I'll answer it in the order that they give us. How long is the frog in the air? No. How long is the frog in the air? 0.75 seconds. Remember, you got to think about it logically. Look, this is like a cross section of how the frog jumped, right? Jumped off the ground and it landed again at 0.75 comma 0, 0.75 seconds. It then asks, what's the maximum height of the frog? Is that x value or y value? The y value. Where at? Right. So what is it? 2.25. Right. So you can answer this question by saying, how long is the frog in the air? The frog's in the air for 3/4 of a second, 0.75 seconds. What is its maximum height? The maximum height is 2.25 feet. Now, if it asked for how long it took to get to that 2.25 feet, what would you say? What's that? No, how long did it take to get to the maximum height? 0.375 seconds. So it's all about interpreting what they're asking you for. That's the difficult part, figuring out the language, figuring out, okay, what is this really asking me? Is it asking me for 0 or maximum, vertex or x-intercept? You got to figure that out, okay, based on the context. All right, now this last example, in my opinion, is something that may be very difficult to remember. And it may be a very, 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 long shot that you actually remember how to do this. I am hoping that this sticks in your brain at least sometime. We're going to do this again a little bit later on to try to get you to do this. I am very surprised that they ask you these kind of questions on your end of course test. I don't know if I would ever ask you these questions in a real life situation, in an actual classroom test. Okay, it says use the table to determine the solutions of the quadratic equation. And honestly, we've given you this, I've seen this exact example on an end of course test. I've seen this exact same thing on an end of course test. The problem with this is you can use a table here. Everybody look at that plus sign. You see how it says add item? Click on that. And look, you can actually input a table into Desmos. Okay? So let's go in and put this table in. Everybody click on table. And let's start plugging in the values. -1, I'm going to arrow over. +1, I'm going to arrow down. 0, -1, 2, 7. And you can kind of scroll out a little bit and see all 3 points. Now, I hope you can see how this is going to look like. There is a quadratic that matches those 3 points. And it will have zeros, but I don't want to just estimate where they are. I want to know exactly where they are. This is how we do this, and you might want to make notes to yourself as we go along. You click into the next box, and you write y, and then you write a little 1. And when you type in 1, it's just going to go down in that as like a subscript. I didn't even need to type anything specific. I just wrote 1, and it knew to go down there. Now, you need a tilde. You guys know what a tilde looks like? Those of you in Spanish class, you do. Okay? A tilde, you see right below the escape key on your keyboards, that squiggly line? It looks like this. That's a tilde. Okay? And you have to hit shift to get it. So shift and then that key gets you that little tilde. Now, we need to write a quadratic. Our standard form of a quadratic is ax squared plus bx plus c, right? So we're going to type in a x. Now, just how I did the y1, I need to do an x1 as well. x1, and then I need to square it. Shift 6 squared. I know. Arrow down, plus bx 1 plus c. That's what it needs to look like. ax1 squared plus bx1 plus c. I know that seems really complicated, but please understand what it is. All the variables just have a little subscript of 1. Did we need to type in or hit shift or anything to get that 1 there? No. So it's y1 tilde, ax squared plus bx plus c, where the x's have the 1s in it. Now, do you see what it did? It made a parabola exactly matching that table. And now I can click and see exactly where the zeros are. Do you see that? It made a parabola exactly matching, going through exactly those 3 coordinates. And now I can plug that in. I can just click on those zeros. So it says use a table to determine the solutions. The solutions are negative 0.707 and 0.707. Those are my answers there. Yes, sir. What's that? It was just given to us on our guided notes there. I just copied and pasted the table from the guided notes into Desmos. Okay, and that's how we write that y1 tilde ax squared plus bx plus c. Okay, so let's go through that whole process again. I'm going to delete everything I have, and I suggest you guys do the same so that we can go from scratch with that, especially if you didn't do it that first time, because this just takes a little bit of practice doing that. So again, the directions on this, we're going to do B here. We're going to do, oh, come on, come back in there. We're going to do this problem down here. Oh, there's a YouTube link right there. Okay, so go ahead and make your table. And now we make our table by hitting the plus sign. And adding in a table. And now we plug in our points. -4, 16, 0, 9, 1, 1. And I might have to zoom out a little bit, but I see my 3 coordinates. Yeah, I'll show you to you in a second. I'll post the video actually that you can just watch here in a second. All right, so we see our parabola. Well, actually, no, we don't see our parabola. We just see the 3 points. So you go down here to your next box, and now I want to input the equation. Again, how we do that, we go y1, y, and then you just type the number 1. It knows to go down into a subscript. You typed it is equal to, and now we got to type in ax squared plus bx plus c. A x1 squared plus b x1 plus, oh, you know what I didn't do? What did I use? I used an equal sign. What should I have used? The tilde. And there it goes. See, even I mess this up sometimes from time to time. Yeah.
I can't figure out how to use the tilde. It's shift what? Shift and then that's
It's the number to the left of 1. It's the key to the left of 1. You see it? And then we can go in and say, okay, well, based on that parabola, the zeros of that equation would have been those two things. Negative 6.5 and 1.1. I will probably remind you several times about that equation right there. That's how to do that within your calculator, within Desmos. Yeah. You know what this is actually showing you? Remember back when we did the lines of best fit, and we said, okay, there was that R value, which was the correlation coefficient, the strength of the correlation. It's showing you based on the table that, look, it's getting you a perfect R value. It's giving you a perfect R value, saying that that quadratic matches exactly to those 3 points. All right, questions on that? Yes.
So what's actually our answer?
It's your answer are the zeros.
Oh.
The zeros, that negative 6.5 and 1.1. Yeah, because it's asking you for the solutions, which means the zeros, the x equals. Yeah. Okay, so no homework tonight. No homework, obviously, over break. But here's what I would like you to do. I would like you to just spend the remaining time. I know we've got, what time is it? It's 9:03. We get out of here at 17. So you got about 15 minutes left. I'm just going to put these problems up on the board. Whoa, whoa, whoa. Okay. And come on. 625 to 626. 2 to 24 even. You do not have to do these as homework. I just want you to use your time for the rest of the class, just kind of practicing this a little bit. My computer's going slow today. My computer already took on spring break. It's like, you know what? No. What's that?
Transformers by my house blew up this morning.
Oh, really?
Yeah, pretty wild.
Did you have it? Did your power go out?
No, it was on the corner, but ours didn't go out. It was really lucky.
Oh, that's good.
The power flickered and our neighbor's power went off, but ours didn't.
But yours did. That's good.
I was in the shower too.
625, 626. All right. Uh-oh, these pages are not in there. Uh-oh. Uh-oh. All right, well, I'm going to turn off the video and then I'll fix this. See you, everybody.